Hello, and welcome back to College Algebra. I had a request to do a video about finding the x and y intercepts of a linear function, so I'm going to show you today how to find the x and y intercepts of any function from the graph, and specifically how to find the x and y intercepts of a linear function algebraically. We're also going to look at doing function evaluation, which is a very, very important thing for you guys to know. Let's get started. So the first way that we're going to look at finding intercepts is just simply by finding intercepts from a graph. Here I have some generic graph of an f of x, and I'd like you to notice a few things about this graph. The first thing I want you to notice is this point right here. So we know that this point has some x and some y value associated with it. What is the y value at this point? Well, since the y-axis starts at 0 and goes to positive infinity, 0 to negative infinity, the y value here is simply 0. We just count for the x value is negative 2. If we go over to the other x-intercept here, we'll notice again that the y value is 0, and the x value is 1, 2, 3, 4. So the other x-intercept of this function is 4, 0. When we go and examine the y-intercept of the function, we want to ask ourselves, what's the x value here? Well, the x-axis goes from 0 to infinity, 0 to negative infinity. That means the x value here is 0. The y value, we just count down. 1, 2, 3. So 0, negative 3. So let's look at finding intercepts algebraically. I'm going to use my favorite linear function, f of x equals 2x minus 3. And I've already taken the liberty of graphing this function for us. Something I want you to notice about this function is wherever it crosses the x-intercept, the y value is 0. Wherever it crosses the y-intercept, the x value is 0. We're going to use this fact to find the x and y intercepts. If we wanted to find the x-intercept, all we have to do to find that is set y to 0 and solve. For example, f of x equals 2x minus 3. Well, that's y equals 2x minus 3. So I'll set y equal to 0 and solve this out. I move the negative 3 over by adding 3 on both sides. I divide everything by 2 to isolate the x. And I get that x equals 3 halves. This means that the x-intercept occurs at 3 halves, 0. And we can see that's true from the graph. For the y-intercept, instead of setting x to 0 or setting y to 0, we're going to set x to 0 and solve. So now y equals 2 times 0 minus 3. Y simply equals negative 3. So the y-intercept occurs at 0, negative 3. Something that's very interesting about how we're doing this is it leads us into function evaluation. So say I wanted to take our function f of x equals 2x plus 3, minus 3, and we're going to evaluate that at x equals 2. So f of 2 equals 2 times 2 minus 3 equals 4 minus 3 equals 1. So f of 2 equals 1. This implies that the point 2, 1 is on the graph of f. And if we go up here, we can see 2, 1 is on the graph of f.
I hope you found that video helpful. If you have any questions for me or would like to see a specific topic covered, feel free to email me or call my Google Voice number. I hope you're all having a great day, and we'll see you next time.